Okay, I've had a couple of questions from the homework. This is from homework 10. And the first question is, what is the IUPAC name of this compound? So the first thing that we want to do is we want to find the longest carbon chain. And remember that the chain does not have to be linear. And so if you look for the longest carbon chain, you can see that it contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. So 10 carbons, and then the next thing we have to do is we have to decide, do we want to start numbering from the carbon on the far left that has the yellow highlighter on it, or maybe I'll replace it with, let's say, a blue highlighter. So I'll put a blue one over here. Do we want to start numbering from here or from here, where the green is? And the answer is we're going to start numbering from the side that has the blue highlighter, because then we have 1, 2, 3, and we have our first substituent at carbon number 3. If we'd start numbering from where the green highlighter is, we'd have 1, 2, 3, 4, 5, 6, and we would have our first substituent at carbon 6. Remember, we want to number the chain in such a way that we give the first substituent the lowest possible number. And so the numbering in red is correct, the numbering in blue is incorrect. And so I'm going to remove those, and I'm going to finish numbering in red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that tells us that this compound is some kind of decane, okay, because that's the parent. Now I circled the 2 carbons that have substituents. At carbon number 3 here, this is an ethyl group. And so we're going to put 3-ethyl. And then on carbon 5, we just have a CH3 group, and that is a methyl group. So that means we have a 5-methyl. And there we have it, 3-ethyl 5-methyl decane. Notice that I put the ethyl first because it begins with the letter E, and I put methyl second because it begins with the letter M. So there you go. That's how you would name that compound. The next question that came up was this one: which of the following is a constitutional isomer of this compound? And so it's referring to this aldehyde here. Keep in mind this is a bond line structure. There's many atoms that aren't written here, right? So we always leave out all hydrogen. So there's a hydrogen here. There's a carbon here. This is a methylene or a CH2. This is another methylene, another methylene, and a methyl group over here. So we have a total of 1, 2, 3, 4, 5 carbons. So this is C5. If you count the hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens and 1 oxygen. So I can see a couple of these possible answers that we can get rid of immediately. If we look at B, for example, we have a total of 1, 2, 3, 4, 5 carbons. So this is C5. And then for the hydrogens, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's C5H12O. So that can't be correct. The same thing is going to apply to D. We have a total of 1, 2, 3, 4, 5 carbons. So this is C5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. So that's C5H12. And of course, there's 1 oxygen. So this one can't be right either. So that brings us to A and C. Now, if we look at A, we see that A has a total of 1, 2, 3, 4, 5 carbons. So we put 5 carbons here. As far as hydrogen goes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So H10O. So this one is a constitutional isomer. And then if we look at the last one, if we look at C, it's got a total of 1, 2, 3, 4, 5 carbons. So C5. And then it has 1 hydrogen here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, C5H10O, and there we have it. So A and C are both constitutional isomers of this compound. So make sure you're really well aware of how to recognize where the hydrogens are in a bond line structure and the carbons as well.